So hello friends, in this video we are going to discuss about UART communication protocol. So let's start this video. So first of all, what is UART? So if you expand the definition of UART, you will get it's universal asynchronous receiver and transmitter. So this is a full definition. So here the main thing you need to understand is the word asynchronous. What is asynchronous? Asynchronous means it doesn't have any clock source, right? So in this communication protocol we do not use any clock, so it doesn't have any clock, right? So no clock is being used here. RX receiver and transmitter means the same device, a single device can work both or act as a both receiver and a transmitter. Okay, like moving forward, it's a half duplex. So again, it's an half duplex. It's an half duplex communication protocol. So what is a half duplex communication protocol? Means at a time only one device can communicate, but now both devices cannot communicate simultaneously. So for those who don't understand what is half duplex and full duplex, so half duplex communication protocol, in half duplex communication only one element can communicate at a time, or only one element can transfer data at a time. And in a full duplex, both master or slave or both elements can transfer data at same time. So this is half duplex and full duplex. Okay, so moving forward towards the connection diagram. So how the connection will connection of UART. So let's say you have one device here, and again you have one device here, right? So yeah, so this is, let's say, your ESP, this is your STM32. You have two devices which both are communicating over UART. So first thing, both will have two pins, RX and TX pins. So the both will have RX and TX pins, right? And the main thing, the TX of the first device shall be connected to the RX of the second, and the RX of the first should be connected to the TX of the second, right? So why so? Because in UART communication you will transmit data over TX pin and you will receive data over RX pin. So TX pin will transmit data and the receiver will receive data over the RX pin. For every RX channel there is an RX buffer, okay, whose size can be configured by your like in your ID or your whatever tools you are using for configuring microcontroller. So there are RX buffer where each data packet coming will be stored in the buffers. So again we will discuss more about this in later videos, but as of now this much is very sufficient. One more important information is that both RX and TX pins of both microcontroller, they are pulled high. Okay, they have internal pull-ups. That means 3.3 volt or 5 volt, whatever logic level your device supports, they are always pulled high. So RX and TX pin are by default pulled high. So we can say they are by default pulled high. They are pulled up by default. Okay. Now moving towards the packet structure. So this is all about the connection diagram and what UART stand for. Now we are moving towards the packet structure of the UART frame. As I told, it doesn't have any clock. So the receiver should understand when he has to start sampling the data and when he has to stop sampling the data. Because if we don't do so, like we will end up reading the garbage. Okay. So this is the complete packet structure of UART. Right, so we'll see one by one. So first, this is the start condition. As I told, RX TX both pins are by default pulled high. So this is your logic 1, right? Logic 1. This is your logic 0. Okay. So by default it is 1. To start the communication, the master has to pull this line to ground. Okay. So you need to pull this line to ground. This transition will result in start condition. So to start, the TX line should go from high to low voltage. Okay, and one more thing, like there is a concept of baud rate. So many of the people were wondering, I haven't told about baud rate yet. So we'll discuss it. As of now, just understand After the start condition, you will send the 8 data packets. You can see D1, D2, D3, D4, so on to D7. D7 means from starting from 0, it's an 8th packet. So this is your data packets. So mostly in a controller, like mostly we use 8-bit frame. So you have 8 bits for the data, representing data, the start condition followed by the 8-bit of data. Now you have done transmitting your 8-bit of data, then how your receiver will know when I stop sampling? For that you will go, like I will choose a different color, from logic 0 to logic 1. This will trigger the stop condition, right? Then we missed one frame, which is a PB. It's a parity. This is an optional frame, like in your ID or tool, whatever you are using for programming a microcontroller. You can specify you need a parity or not. So if you select as a parity, right, then there will be a parity bit, or for the error checking. This is mainly used for the error checking. So what happens if you choose the parity bit? It will append a parity bit according to the number of ones in your frame. Again, if you use the parity, then there is a concept of even parity and odd parity. So if you choose to show the parity, then there comes the concept of even parity and odd parity. So in even parity, out of your 8 data packets, the number of ones, if they are even, the parity bit will be set as 1. If it is odd, it will be set as 0. So this is the parity bit for this UART frame. Okay, then comes the final thing, the baud rate. Okay, then we will discuss the main thing. It's the baud rate. So what is a baud rate? So as it doesn't have any clock, right? So there will be a possibility your master is running at some different clock speed and your slave is running at a different clock speed too. Then what can happen? Let's say you have one signal going on, right? So this is from TX line, it is going on, and there is your receiver. Right? So you are feeding data to the receiver. So what happens? Like say you are sending your data at, let's say, 1 kilohertz frequency, right? And if it's running at let's say 2 kilohertz, then what will happen? It will cut your data and it will sample your data in a wrong manner, because it's processing your data really fast than your master is sending the data with whatever speed your master is sending the data. So in that case, there will be a garbage received on your receiver side. So for that we specify a baud rate. So baud rate is number of symbols transmitted per second, and both master and slave devices should like configure the same baud rate for a same channel if they wish to receive the correct data. So for that whole case, let's say this is a transmitter, they should have the same baud rate. So the most commonly used baud rates are first 9600, or we can say 9600, and second is the 115200. There are more baud rates present in the market, but they are the most important one, and you should be using this baud rate only. So that's all for this video. If you have any doubt, you can leave a comment in the comment section. We will meet in the next video with some more new information about embedded system. Till then, bye bye.